Solution. Sum of individual momentum of the bullet and the object before collision is given by m1u1 plus m2u2. This is equals to 15 times 10 raised to power minus 3 kg times 300 meters per second plus 75 kg times 0, which gives us 4.5 Newton seconds. The mass of object increased after collision. Therefore, the momentum of the system after collision is in bracket m1 plus m2 close bracket v, which is equals to 0.015 plus 75 kg in closing bracket v. From conservation of linear momentum, we have that is 4.5 from before sum of momentum before collision. 4.5 Newton seconds is equals to 75.05 kg. That is the sum of momentum increase after the collision. Therefore, making V the subject of the formula, we now have V equals to 0.06 meters per second. Example 7. Calculate the momentum of a mass of 50 grams traveling at 72 km per hour. Solution. Momentum is equals to mv. Mass is equals to 50 grams. To convert it to kilogram, we have 0.05 kilogram. That is dividing 50 divided by 1000. Velocity is in kilometer per hour. To convert it to meters per second, we times 72 by 1000 and divide by 60 times 60. That is 60 minutes and 60 seconds to give us 20 meters per second. Therefore, the momentum is now equals to 0.05 times 20, which gives us 1 Newton seconds. Example 8. A body of mass 2 kg traveling at 3 meters per second increases its speed to 5 meters per second. When a force Fw acts on it for 0.02 seconds, calculate the momentum of force. Solution. Looking at the diagram, giving positive to the direction of force. A body of 2 kg is moving with 3 meters per second and a force is applied for 0.02 seconds, making the body to increase the speed to 5 meters per second. We are now asked to get the momentum of the force. We know that from momentum, Ft is equals to mv minus mu. F, that is the force times time, which is 0.02 seconds, is equals to mass, which is 2 times initial final velocity, which is 5 meters per second, minus mass, which is 2 times initial velocity u, which is 3. Then we now have F 0.02 seconds is equal to 10 minus 6. Making F the subject of the formula, we now have 4 over 0.02 seconds, which gives us 200 Newton. Example 9. A force of 20 Newton acts on a body of mass 2 kg traveling at 4 meters per second for 0.3 seconds in the direction of its motion. What is the final velocity? Solution. Giving positive direction to the force, a body of mass 2 kg is moving with initial velocity 4 meters per second and a force of 20 Newton is applied for 0.3 seconds. We are now asked to determine the final velocity of the body. From the equation of motion, from the formula of motion, we have that Ft is equals to mass times final velocity minus mass m times initial velocity u. So force is 20 times the time, which is 0.3 seconds, is equals to the mass of the body is 2 times velocity minus the mass 2 times initial velocity u, which is 4. Then we now get 6 is equals to 2v minus 8. Making v the subject of the formula, we now have 6 plus 8 all over 2, which gives us 7 meters per second. Example 10. A body of mass 0.5 kilogram traveling at 3 meters per second encounter a constant frictional force of 2.5 Newton. What is the speed of the body after 2 seconds? Solution. Given positive to the direction of force. A body of mass 0.5 kilogram having initial velocity of 3 meters per second, a force of 2.5 Newton is applied for 2 seconds. We are asked to get the final velocity. From the formula of momentum, we have that force times time Ft is equals to mass m times final velocity v minus mass m times initial velocity. Then substituting the values, we have 2.5 for the force times 2 for the time is equals to minus, since we are giving positive to the direction of force, the final velocity is in the negative direction. So we have 0.5 times v, which is the initial velocity, minus 0.5 times minus 30, since the direction of force is negative. Then we have 5 is equals to minus 0.5 v plus 15. We now take like terms together. We now have 0.5 v is equals to 15 minus 5. 0.5 v will give us 10. Then making v the subject of the formula, we now have 10 over 0.5, which gives us 100 over 5, which is 20 meters per second. Example 11. Two trucks, mass 80 kg and 50 kg, are traveling on the same track with speed of 4 meters per second and 2 meters per second respectively in the same direction. They collide and hook together. With what speed do they combine? Solution. Giving positive to the direction of force. Two trucks. The first truck is having a velocity of 4 meters per second and a weight of 80 kg, while the second is moving with a velocity of 2 meters per second and a mass of 50 kg. The two combine and form a uniform velocity. We are now know that the momentum before they combine is the momentum after they combine. Mass m1 of the first lorry times v, that is velocity of the first lorry, plus mass of the second lorry times velocity of the second lorry is equals to mass of the two lorry times the velocity of the final lorry. We have that 80 times 80, which is the mass of the first lorry, times the speed, which is 4 of the first lorry, plus 50 of the first lorry times 2, that is the speed of velocity, which is supposed to 1/3, which is the sum of the two mass, times v, which is the velocity which